Alright, it's calculator time. And what we're going to do is we're going to look at finding these area under the curves using a TI-84. So again, the standard normal curve, I've mapped things over by using a z-score. So my mean is at 0, my inflection points are at, or my mean is 0, and my standard deviation is 1. And so this is where z equals 1. This is where z equals -1 at these inflection points. Area up to the mean is 50% because it's the halfway point. So if I want to find the area up to -0.99, z equals -0.99, I'm going to go to my TI calculator. And let me turn this on, let me clear that. And I'm going to second and distribution, which is over the vars. And I'm going to want the normal cumulative density function. And so we're going to be cumulative. Now it's going to ask for what the lower number is. Technically the integral it's doing goes to -infinity. We need to put a large number in. So I just put in -1 e to the 99. I just put in a large number. I think your book says put in 10,000, which would be -1 e to the 4th. But I just put in -1 e to the 99, so it's in there. Then my upper value is the z-score I'm looking at, 0.99. And then my mu, my mean is 0, and my standard deviation is 1. And I paste that in. Now some of you might have a calculator that it does not give you the table to put in. It just gives you the normal CDF and it drops you to parentheses. So in your first will be the lower number, which is -1 e to the 99. Then the upper number, which is the z-score we're looking at, -0.99, comma the mean, comma the standard deviation. And I hit enter to this, and I get 0.160876062 as being my value. I think the table, if we were to look it up, is 0.1611 because it rounded. Alright, so I'm just going to put a note of this on the blackboard as we switch over here. So I'll come here. And so the probability of z being less than negative, and I'm going to use the less than, right? Because that's saying the probability of picking anything up to that line was 0.16108, and we round it up. Alright, so when we look at this, what we entered on the calculator was a normal cumulative density function. We put a very low number for the lower bound. We put our actual z in here. And because it was a standard normal, we had 0 for the mean and 1 for the standard deviation. So if I were to talk about this generally, the normal CDF is that Z1, the lower one, Z2, the upper one, the mean, and the standard deviation. And so we're going to come back to this in many different forms. For right now, I'm going to look at different z-scores. We're going to do a low one, a high one, what's to the left and what's in the middle, just like I did with the tables. Alright, so now we want to know the cumulative distribution up to z equals 1.06. And let's look for the things to the right of z equals 1.06. So we have a z-score of 1.06, and we want the stuff on the right tail here. And if we remember, the probability of being greater than 1.06 is 1 minus the probability of being less than 1.06. And so what we want to do here is we want to, in our calculator, do 1 minus the normal CDF of -1 to a large number, comma 1.06 for the z we're looking at, comma 0, comma 1. And let me show you that on the calculator right now. 1 minus, I go to second and distributions, and I'll use the normal CDF. And the only thing I have to change here is this is now 1.06. So enter, enter, I'll paste all that in, and I get that everything to the right of that is 1.4457. I think if you use the tables in the book, you get 1446. Oh, that did not show up over here. Let me do that again really quick. My apologies for the calculator not showing up, but I'll redo it. I'll do second and distribution. I go to normal CD. Oh, let me quit out of here. Do it all. I did 1 minus second and distribution. I chose the normal CDF. I put in my lower bound, which is somewhere near negative infinity. Notice the E is to a really big number. My upper bound, 1.06, my mu, and my standard deviation. And when I plop that all in, that gives me the number I want. Let's come back over here to the blackboard and scrape this down for a second. Whoops. Dropped my pen! I dropped my pen! Okay, I picked up my pen. We're better now. And we get negative 1.4457, which we approximate to 0.1446. Alright, I'm going to show you another way you can do this on the calculator. You can have the calculator do in-between values. It's cumulative distribution, so I can do second vars, normal CDF, and I can say my lower is the 1.06. And my upper is going to be some number near infinity. So again, I'm going to use the 99. And then I'm going to paste that in. And notice I get the 1.44572374. So this normal CDF function on the calculator, we don't have to worry about left and right as much as we do about knowing what our range is, if we remember that it's the lower, comma, the upper. And that'll help us here for the area between two Z values. So let's look at the area between two Z values. So let me come over here. Let me show this again. For some reason it jumps back and forth from the calculator bit going through, but I'll just repeat this here. And so I can, in the calculator, enter in my lower number being the 1.06, and then I go up to 1 to the 99th, some big number towards infinity. I make my mean 0 and my standard distribution 1, and that gives me the same value. And what I'm going to do here is I'm going to do between two Z scores using this idea. So if I want to find the area under the curve between Z equals negative 1.5 and Z equals 1.25. Instead of doing this minus this, I can use the normal CDF, and I can do a negative 1.5 for my lower Z, a 1.25 for my upper, a mean of 0, and a standard deviation of 1. And that'll pop out the answer for me, which is going to be around 0.82, just from the tables I've looked at. But let's look at this directly. All right, got the calculator this time. Hopefully it won't slip away on us here. So I go to second and distributions, come down to the normal cumulative density function. I say that my lower is the negative 1.5, my lower Z. I say my upper is 1.25, and that my mean is 1 and my standard deviation is 1. And so if we look at what's in my normal CDF function in the parentheses here, I have my lower Z, comma my higher Z, the mean, and the standard deviation. And that pops out 0.8275, which we would get the same way as doing the tables. So the idea is, right, we can look these up in the table, we can sketch them out, we could even do the integrals if we wanted to do the Calc 2 way of doing all this. But we have a little piece of technology either with the tables or with our calculator that will tell us the area under the curve in a normal distribution. And remember, area is probability. Area is probability. And that's our translational tool for us. Okay, what did this say this was? This came out and told me this was 0.82, what was the other? 754. 4, dot, 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 dot. All right. We will continue exploring probabilities because we now need to change these from the standard normal back to the original things we were measuring. And so there's a little bit of translation to go on.